Nice text, Jen. Oh, so this is where you'll get the So you've got
we have to mute that. Okay, I think we should be okay now.
Okay.
Okay now.
Okay. Okay. Oh. Is that a bit of an echo?
We had an echo, I think.
Yeah, we do, didn't we?
I got this muted.
No.
Okay.
No. That's it. That's better. Oh, it's weird, isn't it?
You're sitting in a chair, Dave.
I know.
Is it that slow?
Excellent.
So ask Jen if we're live yet. I can do it on here, actually.
Right.
Hello, Mike. Can you hear us?
I bet he's just Mike's gone in and just gone away for a cup of tea.
I'll go one more.
Okay.
That's coming up.
You getting sound?
No, it just says live.
Do you want to go outside? See if you're getting some sound.
Say something, Dave.
Hello, David. Are you we're getting live sound? Can you hear it?
I can see you. I'm not getting sound.
Ah, we haven't got a share sound or something, have we?
I'm getting sound now.
Oh, okay. Okay, that's all right then. Yeah. Blimey.
We're about 20 seconds behind. That's not working.
That's okay.
So you're going to kick off with a little demonstration thing?
Oh, I was going to do a little talk.
Yeah.
Take about 20 minutes.
Yeah.
Let's get that up. Just going to show a few pictures, David, show them what we could or may not be able to see tonight. A little bit of what it's like becoming a member, the usual sort of. So, oh, I was moved to tears, said David Strange. Right. I know, that's the best way. What do you do with the YouTube? Just minimize it.
Actually, minimize it.
Right, Guillermo, let's get you in. Right. Oh.
Shall I unlock the front door, Dave?
I've done it, David. I've
You have?
locked the side door and opened that one.
Okay.
I've put the light on as well. That's it.
Blue stacks.
Okay. Just come out of it. Good evening.
Hi.
Yeah, yeah, which is yeah, I know. There's a lot of people looking from home. So
Yeah, well, that's what I wondered. I thought that might be the case. Yeah.
yeah, just make yourself comfortable. Thank you. First time up here?
Yes, yeah.
I'm just interested, you know.
Well, I've got an old friend when I was at university 40, 50 years ago.
Yeah.
He used to come here. Actually, we did physics together and he did astrophysics.
Oh, okay.
So he used to come up and do a project up here
Oh,
every
okay.
year, quite often. Actually.
Yeah. Who was he? Do anybody we might know?
No, I don't think so. David Tone, I suppose you.
No.
David Tone, Lee Jones.
Some of the older ones might remember it. If Johnny Posters.
Cloudy, I'm afraid.
Yeah, at the moment, we sat earlier. And hopefully, some of our members, if they look, it might be clearer.
Right, so it's all set up.
Right,
Rolling.
okay.
When you finish, you'll talk to me.
Okay. I'll give him 5 more minutes. Mike's not going to come in, is he? And speak to us.
Well, you said you'd have this telescope online by 8 o'clock or 5.
Yeah.
It's not really very dark at the moment, is it, actually?
Yeah, I would say aiming to start viewing possibly around about 8 o'clock. We'll go for something bright like Jupiter, which we should get soon. That sort of
I
time.
think Jupiter will rise at about 9.
Oh, will it? Okay.
Saturn should be there.
Yeah.
There's clouds at the moment. Never mind.
Good evening, Mike.
Good evening.
Yeah.
I didn't bring any clearance slides, sorry.
We are live on YouTube.
Yeah.
Yes, yes, and the wife can hear everything we say and do. Yeah. So you live in Sidmouth?
Yes, yeah.
Yeah.
Been meaning to get up here ever since
We moved here, yeah.
we moved in during COVID.
Oh, okay,
Yeah.
okay.
Everything's taken a lot longer to do.
Yeah, I'm quite lucky because of COVID. I could come up here and cut the grass. Yeah, so it was an excuse to get out of the house.
Yeah.
David had a few problems with the consignment of manure though, didn't you, David?
I did, yeah. Made front page Super Herald.
It did, yeah.
Did you? We're trying to deliver it up here.
It got stopped on the M5 by the police.
Oh, right.
It was an unessential delivery.
Yeah.
I said, I'm digging for victory.
Hope you didn't get fined.
You blogged about it all, thing, and you got Hernandez, didn't you? Apology.
Yes, I put a complaint on Twitter at Devon Court Police, and they apologised. Said that, yes, the officer was beyond his remit.
Yeah.
Yeah. It's quite a bit of that, I think.
Hmm.
How long has this place been here?
Since 1912.
Yeah.
Yeah. Lockyer was in his 76th year when he retired. He built his retirement home, and his friends gave him money to set up a new observatory here.
So you're still around, so how old, so when did he die? Was it?
He
20.
died in 1920,
Yeah.
and his son James Lockyer took over, and he died in 1936. And then it was privately funded, so it was run by the Northern Lockyer Corporation. They ran out of money in the 1960s. The last resident astronomer, a chap called John Barber, retired, and then it was taken over by the university.
Yeah, I think I was there in 79. Well, finished in, or 78, finished 77, 78. And these friends of mine used to come up pretty well most nights to do their physics project up here.
Yeah, they were doing geophysics research here.
Yeah, right, yeah.
But no astronomy, and then Exeter wanted to set it all off in the 1980s for development. And good people, Sidmouth, headed by Patrick Moore, saved austerity. They raised around 1,000 and gave money to the council and then the site.
Hello,
Hi.
good evening.
Good, thank you.
Good. Well, please come in, sit down, make yourself comfortable.
Missed anything?
No,
Well, you have, unfortunately. You missed Saturn.
we start fishing in 2 minutes.
Yeah, I'll give it a couple of minutes extra, but yes. So hopefully, yeah, David will keep an eye on the sky.
I'll keep an eye on.
Yeah. Security. Yeah. And yes, so we've got Mike.
That's me.
No, Mike.
Mike.
Mike, yeah. And hopefully, if we can't see anything, Mike might be able to see anything, because where is he, Plymouth? Yeah, so we might get lucky. If not, we'll show you some pretty pictures and we'll talk away. So I'm Dave Alexander, Mike Hutchings. You met David Strange, the chair. So you two look like you first time up here as well.
Yeah.
Okay, I'll draw your attention to the Family Fun Day.
Is this on Sunday?
That's on Sunday, yeah. So I say children loosely, young adults, 17 or under get in free, but adults pay £10. There is loads and loads of things to do. There's storytelling in the planetarium. There's rockets. We've got lectures, which you might be interested. We've got Professor Brian Clegg talking about interplanetary travel. We've got somebody talking about, Dr. Des Howlett talking about, is there life out in the universe? So there is, mainly it's children focused. And what the highlight of the day is the rocket cars. And this is where dad bonds with his son or his daughter, because they get given a piece of polystyrene, they mold it, they put their wheels onto it, there's a workshop, and then we put a little jet engine in it. And the first year, I don't know if you was here, Mike, the first year, they had children sitting on the edge, either side of the pavement of the path out there, and they sent the first rocket car down, and it hit 84 miles an hour. And you think, hang on a minute, we got they're sort of there, you know. So we had to drill holes in the kit and then put a cable through. They're still getting up to 70 miles an hour. So yeah, so it's good fun. And there's lots, and you can sort of wander around the site. There's history talks where somebody will take you on an interpretive tour of the site and tell you a bit about the people behind the domes, because there were some very, very interesting people involved in this place. And that's about it. So let's get me glasses. What do we do? Give it a couple more minutes?
Yeah, no, you're good to go. Cross over now.
Okay, okay. Oh, right, okay. This is a bit surreal here. Yeah, just talking to 4 people and the internet. Okay, okay. Good evening, everybody. Welcome to the Lockyer Observatory. This is an event that there's people here, but to all of you watching online, then welcome. This event, live streaming, is in partnership with the Sidmouth Science Festival, which is in its 13th year. It's one of the largest science festivals. In fact, it is the largest volunteer-run festival in the UK, and they're investigating whether it is the largest one in Europe. Last year, we set a world record for the world's longest tin can telephone, which we beat by 130 odd feet. Anyway, and so yes, tonight you got David, you got myself, Dave Alexander, you got Mike, Curran online. Okay, domestics. Well, for you people here, that's the fire exit. Gents' toilet is just outside here. Ladies' toilet just right and then left. Walk towards the planetarium doors, and you'll find the ladies. For you people at home, well, I would hope you knew where your fire exit is, and I would certainly hope you knew where your toilets were. Anyway, so what's happening tonight? Okay, so basically a little introduction. Live streaming from 8, hopefully. For those of you, if you're interested, we'll take you out and show you the equipment that we're streaming from. And later on, you'll be invited if you want. We'll take requests and we'll go and look at things that you may want to look at, providing they're above the horizon. Sorry, excuse me. So you're set up for tonight. If you go down to the Victoria Dome, we're using a Celestron C11. We're using a modern CMOS dedicated camera, an ASI ZWO, ASI 533 single shot color camera. And we're using this gadget here. And this is a wonderful piece of gadget. I'd imagine there's wives all over the country really pleased that this piece of kit comes online, because effectively it's a transmitter. So it does everything possible that you need for your telescope to do, and then you can control it, images, all sorts of things remotely. And that's what we're doing tonight. That piece of kit is sitting on the telescope in the dome down there. Unfortunately, it's out of range, so the lads have hardwired it in, but it's cabled to here. Yeah, very, and it's not very expensive. Really, all it is, it's a Raspberry Pi with a few extra add-ons to make it beneficial for astronomers. So yes, that's what you'll be seeing later. Okay, the hard sell. Membership of the NLO is £25 per year individual, or £40 per couple. Members' nights every Friday. Free entry to all the open evenings. Training on the old antique telescopes and the new telescopes. And the wonderful thing here is that the telescopes are well over 150 years old. We still use them. They are some nice telescopes. You go on to a mailing list. We have ad hoc observing sessions up here. So if it's clear, myself and Hugh, David or Mike will come up and we will open up, and you can just look through the telescopes or just ask us what we're doing. There are other interest groups. We've got Mike Curran up there. You can see Mike runs the cosmology group. I'm not a member of the, I don't subscribe to the group. They meet on Zoom. because I'm befuddled enough as it is already. But it is Mike does a pretty impressive job. The briefings that he sends out are really, really superb. And I'm really excited to see his next briefing, because I don't know if you've heard about jumbos. Yeah, you've heard about them. Yeah, these multiple Jupiter-sized objects that are not gravitationally bound to a star that James Webb has found wandering in the Orion Nebula. And the weird thing is they're in pairs, and they don't understand why. But hey ho, that's the James Webb. It's really challenging our understanding of the universe, and that's what it was there for. That's why they paid the big bucks, didn't they? Okay, some of the things that we do, I ain't going to talk too much, but the sun's been pretty active. I think you're probably all aware that we've been getting some pretty impressive solar flares, aurora borealis. We have seen the aurora here. David's taken pictures just from the top of the hill here. We have in the LTC Technology Centre, we have cameras looking at meteors, and they've actually picked up the start of aurora forming. The reason I took these pictures, it was this. I just held my mobile phone up to one of our solar telescopes, took a picture. This is an absolutely humongous, and I mean humongous, solar flare. Fortunately, not pointing at us, so pointing away from us. However, 6th of July, David was showing round a group of scouts, and he happened to be in the technology centre where the lads do some pretty clever things. And David noticed that the very low frequency detector had picked up at 7 p.m. this solar flare, a huge solar flare. It was also picked up by one of our members, Dave Jones in Chard. Hi, mate. Picked up by Dave Jones in Chard, and sure enough, we had some splendid aurora displays, particularly in Scotland. This is a picture that David took. David has a dedicated telescope, and this is a rather large sunspot, and it could be seen by Mars. And I said to David, I said, so what? How do we know? How do we know that we can see this from Mars? And what's the point? And David explained that, and it's something I never realised, the Mars rovers, they are constantly monitoring the sun. And they are monitoring the sun because they're looking for a degradation in the quality of the image, because that means there's a sandstorm on the way, and it knows it can hunker down. And that's purely that reason, that it's just there for weather to look for storms heading its way. Okay, for those of you at home, for those of you here, the basics are, what do you need for astronomy? You can do naked eye astronomy. You can go out there, and there's plenty of visual work that you can do. You can do meteor counts. So you count the meteor displays. We've got a big one coming up in December, the Geminids, which will be no moon, basically. So you'll get to see some of the fainter meteors. If you've got a pair of binoculars, binoculars, you'll be surprised at what you can see through a good pair of binoculars. Pair of 10 by 50 binoculars. What we tend to recommend is, if you've got children that are getting interested in astronomy, what you can do is just buy them a pair of 10 by 50 binoculars. And the beauty of those is they can use them for astronomy, but also you can use them for daytime bird watching, watching planes, watching things. And we do tell people, cruise to charity shops the charity shops will sell, often sell off camera tripods. And then if you need the adapter for them, just speak to the lads at First Light Optics, email them and they'll advise you on what you need. Sorry, excuse me. Okay, so you're going to go into a telescope. You're going to go in and do some astronomy. What can you see? This is a wide field refractor, quite inexpensive, around about 600, 700 £700. Obviously, you need a tripod to put it on. And this was basically 15, this is basically 30 minutes of exposures. So 15 2-minute exposures stacked. I used a dedicated camera. And as you can see, what you're starting to see here, you're starting to see one of the many regions of hydrogen regions in our galaxy along the arms of the Milky Way. And the reason that people tend to image these is because they're quite attractive. They make nice pictures. It looks like they're very interesting. So here you've got a star called Saturn in the constellation of Cygnus. So you've got this H2 region here. You're starting to pick up this H2 region. But the thing I love about wide field photography is you pick up the other things. This is called the Rocking Horse cluster. So this is an open cluster. This is a group of stars that have all formed in the same cloud of gas and dust. And over the time, they've used up their material. And as these stars start to shine, as they create the solar wind, the remaining gas is just blown away. So that's what you can do with a small dedicated telescope. Now, the weird thing is, this is just a spotting scope. This will set you back around £200. This is just really a finder scope for using with a larger telescope. But the weird thing, or not the weird thing, but the unusual thing here is that the glass, the manufacture of this thing, has been done to such a high standard that effectively you can use it as a small telescope, as a small wide field telescope. And again, to demonstrate this, I did 21-minute exposures, so 20 minutes of exposures. This is star Saturn. This is the hydrogen region. There's the Rocking Horse cluster. It's now picked up another cluster here. So obviously what you're getting a wider field of view. But the remarkable thing is that you can get some decent images out of something that is effectively a finder scope, and only really used to support the main telescope to find objects. Then, well, you've got a digital SLR camera. So what you can do with your digital SLR camera, you can, again, if you've got a good quality tripod and tracking, you can take the same region. There's Saturn now, but obviously now you've got a wider field of view. So really what you are starting to see is just how big this hydrogen region is around this star. So you're starting to get a wider field of view. You're starting to get a bigger picture of what's happening. But more importantly, again, the pleasure of wide field photography is hopefully you can just about see that. Can you see that? Yeah, okay. Yeah. That is called the Crescent Nebula. It's effectively a Wolf-Rayet star. It's named after the first star that was discovered of this type, and it was named by the astronomers that found it. And effectively, this star is just undergoing, well, basically violent ejection of its atmosphere and everything. It's just throwing stuff off. It's just getting rid of it as quick as it can. The belief is that stars like these are getting ready to go supernova, but not in our lifetime, unfortunately. So that image was only 9 minutes, 30 seconds. So that was 19 30-second exposures. So if you do longer, you'll pull out even more of the detail in this thing. Finally, you buy a camera, your digital SLR camera, in this case, I bought Canon, and I got this lens, and I just thought I'd have a little play with it. And what you can do is, you might have heard of something called the 500 rule. So effectively what you're doing is, if you set that to 20 millimeters, you've got your settings there, divide them into 500, and that will tell you how long you can have that shutter open before you start to get star traps. And again, that's on a static tripod. This was on a static tripod. So I had it on a 20-second exposure, a 20 millimeter lens setting. Divide that into 500, you got 25. So I had the lens open for 25 minutes looking at Orion. And again, this was only 3 minutes worth of, under 3 minutes worth of exposures. So again, if you're doing longer, you put in more detail. But what have you got? Well, you've got the Orion Nebula here, quite clearly. Nice binocular object, but you start to see color because the eye can't pick up color. You've got the Running Man Nebula here. You come up here, you can see the Flame Nebula. If you set the exposure shutter open longer, take more pictures, you possibly could have picked up the Horsehead Nebula, because that's around here. And then there's other things that you can pick here, because in Orion, this is a massive star forming region. You've got these stars here. Yeah. And I hope people on YouTube, you can see my cursor going around. Oh, no, back. So yeah, so what you've got there, that is called Colander 70. It's an open cluster. It's basically, it is an association of very young, very hot stars classified as O and B. They're the youngest, the largest, and the hottest of the stars. They won't last very long. They'll last around about 100 million years, and they'll start going supernova. But what they do is, in the process of going nova, they will seed stars and that around them with the heavy elements, carbon and that sort of thing. But just setting your digital SLR camera to take that picture, just experiment. You'd be surprised. This is another picture that I took now. This is another Wolf-Rayet star. You'll see it clearer in a minute in my next picture. But this was taken with a small 73 millimeter refractor and a 200D, a Canon 200D digital SLR camera. What you've got, you can't see it very well, is you've got the bubble nebula. So you've got a hydrogen 2 region of the Milky Way. You've got a larger region that's been picked up here. But what I like is you've got this, and this is Messier 52. Charles Messier was a compiler of what he called nuisance objects, because he was only interested in comets. He was fed up with people coming to him and saying, look, I found this. And then he realized it's not a comet. So he compiled what we now know is the first catalogue of deep sky objects. And that's number 52. So this picture, there's a lot in it. Okay, that's with the Canon digital SLR. So a dedicated astronomy camera now. So this is this ASI 533 one-shot color camera. Now, hopefully, you can see the bubble. This is another Wolf-Rayet star. This is another star undergoing violent change. Again, we still have M52 open cluster. So again, there's a lot in this picture. So the cameras can pick up a lot. And here is the bubble in all its glory. That was taken with the telescope we'll be using tonight. Now, the difference between this telescope that you will be using tonight is it's not a wide field telescope, so you won't get these huge vistas that we get with wide field refractors and the lenses on digital SLR cameras. This really is for narrowing down, zooming in on your dark objects, on your small deep sky objects. And yet, so this is, and again, this is only 20 minutes worth of shots. But yeah, you can see it there, the bubble nebula. And we may see that tonight. Possible targets for tonight. The Andromedan galaxy is an old favorite. So if it's clear, we can show you that. M51 spiral galaxy in Cantabile. These are all pictures that we've taken as members up here at the observatory. How are we going, David?
Yeah, we've got something anyway.
Okay, good. Okay, globular cluster. Again, this was with a Canon camera. It's only 30-second exposure, so it's only 15 minutes. Globular cluster, this is, there's a number of these. They're quite impressive objects to see through binoculars. And then tonight, hopefully, David might show us the comet 12P Pons-Brooks comet, or as people are calling it, the Millennium Falcon, because it's got that sort of shape. And this, we believe, is a comet. Good evening. Do you want to come in and sit down? So this is a comet that we believe is in the process of breaking up. But then again, it may not. Also tonight, yeah, it's got Jupiter, Uranus and Neptune around there, aren't they, David?
Yes,
Yeah.
yeah, they're behind the clouds at the moment.
Yeah. This is my first picture I've taken, and I was well chuffed to bits. So I took this a few nights ago, first time. Okay, things you won't be seeing. Double cluster in Perseus. If you've got a pair of binoculars, this is a must go to. Look, just look between Cassiopeia and Perseus. So you're looking for the W in the sky. The telescope we've got here would not show this in any sort of formal or that you can really appreciate. You need a wide field pair of binoculars or a telescope. You've got these two magnificent clusters, very, very rich, very, very young, independent of each other, but well worth it through binoculars. This, again, the Pleiades are starting to come now into the evening sky. The left was taken through a telescope. You're starting to pick up the nebulosity. This is called the Merope Nebula. This was taken on a static tripod with my Canon 200D camera. This was only 3 minutes, 20-second exposure on a 135mm setting. And again, what you are doing is you are starting to pick up the cluster in all its glory. You're just amazingly just starting to pick up some of the nebulosity associated with this. Right, okay. This is another picture that I've taken. This was an early picture, just again, static picture. This is the Hyades in Taurus. This is Aldebaran. The reason for this is Aldebaran is believed to form from the same cloud of gas and material as our sun. The Hyades, loose open cluster of stars also associated with our sun. And again, you're looking at the picture, and then you've picked up down here NGC 1665, nice little open cluster. So sometimes that would be a binocular object, but the cameras pick that up as well. And sometimes a camera will pick up things that you cannot see. Right, sorry about this. Yeah, this is my favourite picture. And I normally ask children, where do you think this picture was taken? And they normally say Antarctica. And this is Mars. Now, I've got to tell you something. I wish I'd learned and sat and studied maths, because this, what I'm going to tell you now, is staggering. Okay, this is a volcano, an extinct volcanic cone. Okay, Mars Reconnaissance Orbiter is going over and takes this image. NASA knows the exact time that this picture was taken. They know the exact location of the orbiter when it was taken. They know the exact position of the sun when this picture was taken. And they look at that shadow there. And they know that that opening is 33 meters wide. And they know that the depth from there to there is 95 meters. And they also have reason to believe that there are little volcanic tubes going about 130 to 170 meters in two directions. Why is it important? Well, I find that staggering, but why is it important? Because that's where we're going to live. Because that's where the astronauts will go. Because they will find places like these to get into and to live, because the surface will protect them from the harsh radiation. So yeah, that's my favorite picture. Any questions? No? Okay. Right then, David.
Okay, so we've got the little Victoria telescope live at the moment, imaging. Unfortunately, I had hoped to have a look at Saturn, but it's hiding behind the clouds, but it's a clear slot overhead. So we are going to have, I think we'll stop sharing that, and I'll share. Here we go, share that one. So what we've got here, can people on Zoom see that? We've got a little smoke ring in the sky. This is the famous Ring Nebula, very near Vega. Vega is a very bright star you see overhead right now. There's a lot of clouds all lurking below, but there's a slightly clear spot up above. And it should be on live stat mode. Actually, I think I might have to log in again, because there we go. Yes, it was connected up using my phone, and I've got to refresh. So let me explain what's happening. The image here of M57, it should be stacking the pictures. We have a little, what's called a guide telescope. This little graph at the top is making alterations in the north, south, east, west direction. So RA stands for right ascension, that's east, west. DEC stands for declination, that's north, south. So it's there's a little sensitive imaging camera, has a little crosshair on it, and it can work out when the star is either drifting north, south, or east or west, and it can bring that star back to the central line. The idea of that is so all these stars remain as little tiny pinpoints. So it's making a guiding correction now. That should soon get back to the horizontal line. Yeah, so it's correcting itself. So while all that's happening, we are taking 30-second shots. and it should start stacking them. And the whole idea of this astroimaging is to take lots of photos and stack them all together, and that will give you a cleaner image. You will see this, what we call this background noise, will in course of time, in half a dozen exposures, that will darken, and you'll get a cleaner image of the little ring nebula itself. So what you're actually seeing here is a central star. This is a white dwarf star, incredibly dense material. And this is the star at the end of its life, and it's probably what's going to happen to our sun. The white dwarf star is basically when the star is thrown off this outer atmosphere, this expanding ring, probably an explosion happened about 6,000 years ago. In time, all this ring will expand and dissipate into space, and all this material will get recycled into new stars. And the little star left behind is a white dwarf star, really dense neutronic material. All the atoms, the electrons and the protons are all fused together to form a little neutron star in the center there. And all the other stars here, of course, are foreground stars or further stars. What you're actually looking through in space is more like sort of layers of an onion ring. So some objects can be near us and some can be more remote. There is a little faint galaxy that might appear somewhere up here soon. And this object is probably about 6,000 light years away. When you see a little galaxy appear, that is probably an order of 20, 30 million light years away. So we've now stacked 3, so it's stacked 4. Now the other thing to note, the temperature, it's running at -10 degrees centigrade. The lower the temperature you can keep your electronics, the better the system will operate. You get less what we call thermal noise. That's why all these space telescopes, like James Webb and Hubble, use cryogenic cooling, liquid helium to cool everything. So the other thing to note is the colors. As Dave pointed out, this reddish glow around the edge is caused by hydrogen alpha emission. That's the excited state of hydrogen atoms. And the greeny blue is excited oxygen atoms called O3. Our eyes aren't really sensitive to color, not a faint object like this. When you look through a telescope, you just see a grey misty patch of light. But the color camera is more sensitive, so it can pick out the colors. So we'll do a few more. It's looking reasonably clear out there. So perhaps what we'll do next, is in the same part of the sky is this exploding comet, Comet Pons-Brooks. So what we'll do, we do one more. The other thing we can do, you can see this little graph at the bottom, press zoom. This is called a histogram. So this is the brightness levels of all the pixels in this camera. So the camera is about 3008 by 3008 little tiny pixels, 3000 that way, 3000 that way. This is the brightness range. These are the dark pixels here and the bright pixels over here. And what we can do by using these sliders, we can cut off the dark point to make the background slide darker. We go there. And we can brighten the object by moving this in. So actually, probably better if we move that out. Move that one over. So if you want to get a nice clear picture, I'm just doing it's called a live stack. So literally the software is stacking each 30-second picture on top of one another. But if we want to get a nice clean picture, what we would do, we would take perhaps longer exposures and we will stack all these images in some stacking software. If you're a purist, you can do things like dark frames and flat fields that take out all the background noise from the camera itself. So we've done 10, so we'll stop there. And we'll save that picture and put it on the web page later on. So what we'll do now, we'll go and see if we can find this comet. So how we find a comet, we click that little section there. Pops up. So click go to. We might have to move the dome, Dave. Could you pop out and just see if the dome isn't automated yet? So we've actually, the telescope's loose, we've got to move, of course, the shutter of the dome. So the clever thing about this software, it knows where the comet is in the sky. It will take a picture, that's 5 seconds. It will detect the stars. And if it's not on target, it will slew the telescope till it finds the right target. So there, it's finished. It's found Comet Ponsbrook. And what we will do is we will put it in live mode. Actually, we need to reset the guide scope. So the guide scope is hopefully going to find these little stars. That's a satellite trail that whizzed through. Probably one of Mr. Musk's horrible satellite arrays. There we are, it's picked up a guide star. It should start guiding now. There's a little faint fuzzy patch right in the center there. What we will do put on live mode. We'll go up to 60 seconds.
How are we doing?
Yeah, we got the comet. So this particular comet it's called a periodic comet. It was discovered about 1814 by French astronomer Jean-Luc Pons, and it was always picked up a few years later by Dr. Brooks. So comets, if you discover a comet, you get it named after you. So this comet is shared by Mr. Pons and Mr. Brooks. And it is a Halley-type comet, so it comes around every 70 years. And it will be at its brightest next April. Now, what is surprising about this comet is normally they get active when they come near the sun, and the sun, of course, melts the ice and the rocks, and you get a lovely tail form. This comet at the moment is out beyond the orbit of Jupiter, so there's not any reason for it to explode like this. What we think is happening is cryogenic volcanism that happened on October the 5th. It was picked up. This comet did actually have an outburst last July, and it grew these curious little horns. It looks like, as Dave said, the Millennium Falcon spacecraft. And then it faded, and now it's gone in an outburst again. So we're just waiting for the picture, come through. Just the brightness. So there you see a little fuzzy ball, and the two little horns coming out this way. Now, unfortunately, the comet, of course, is moving against the background stars. So the software will probably stack on the stars, but you might see the comet get elongated this way because the comet is moving appreciably against the background stars with each 60-second exposure you take. But you might be all right for 5 or 6 minutes. We'll see how it goes.
David,
Hello?
if you want, I can show M31 Andromeda Galaxy while you're stacking it.
Oh, well done. Okay. I'm going to stop sharing now, Mike, and then we'll switch over to you. So Mike Curran is in Sidmouth, imaging from his back garden.
Yep.
So over to you, Mike.
Okay, and I should be able to share. Right, that's a picture at the moment of my guide camera. I've got cloud. However, I started stacking this about good half an hour ago. This is the Andromeda Galaxy. It's the closest large galaxy to the Milky Way. It's about 2.5 million light years away. And it's actually heading towards us. So if you're around in 4 billion years, there'll be quite a spectacular collision happening. Anyway, this is the. I'm using a similar setup today to David, except I've got a portable setup. If I just briefly show you if I can find it. Right, this is my setup in the garden. It's a Skywatcher mount. I've got a 250 millimeter telescope here, and a cooled camera. It's the ASI 533, similar to the one David's using. Up on top here is just a little mini guide scope, and I use the camera that I normally use for looking at Saturn and Jupiter and so on, and I use that as a guide camera. So as I say, that's the basic setup. Looking at the other side, this is the little ASI computer box that sits on top.
It's actually a Raspberry Pi box, and it's been programmed with all of the star charts and programmed to control the mount and the cameras, the guide cameras, and so on. And this little thing on the top here is a little travel router. Because this is an old version of the ASI Air, it doesn't have an aerial. It doesn't link in. But so what this box is doing is actually linking it into my home Wi-Fi system. So, okay, this is the stack I've done up to now. It's stacked 28 1-minute shots, and you can see now if I just take the histogram out of the way. So you're beginning to see some structure now within the galaxy. You can see a dark dust lane in there, and there's a little bit of structure around the bottom as well. So to get good shots of this, you probably need to stack something like 50 or 60 shots. So you need quite a bit of storage space. So, right, I think I'll pass it back to you then, David, if you want to see how you're getting on with that comet.
Many thanks, Mike. Right, if we go back to our comet. So you can now see little horns appearing. The little star in the center is the actual comet nucleus. The comet nucleus is very tiny. The first comet nucleus we got up close to was, of course, Halley's comet back in, was it in the 80s, wasn't it, I think? So they're only tens of miles in diameter. The largest comet we know about was Comet Hale-Bopp, that wonderful object we saw in 1997. That had a nucleus diameter about 50 miles. So we now stacked 8 1-minute shots, and you can see this little horned appearance of the comet. If I click on that, you can zoom in a bit more. A bit pixelated. But there we go. Right, so we'll do one more and then we'll save that. So the sky is it pretty clear up there, Dave?
Yes, it is looking quite good now, David.
What about any sort of, perhaps we'll have a look at M13 in Hercules, and then we'll go and try and find some planets.
Yeah.
We'll just do one last minute exposure on here coming up. So this would have effectively been 10 minutes worth of exposing on that little comet. Okay, we'll stop that there, and we will save that image for later on. Right, what we'll do now, we'll go and Messier objects, these are all catalogued after the French astronomer Charles Messier, who was actually looking for comets, but he made a catalogue of these fuzzy objects in the sky, and he's more famous for his catalogue of fuzzy objects than he is for the comets that he discovered.
Well, am I going to need to go and check?
Yeah, you might do.
Okay.
We're now gone slightly over to the west from the comet, a little bit lower in the sky. This object, Messier 13, is a wonderful globular star cluster it's a binocular object. You can see it, we call it the keystone of Hercules, where it lies. It's the main sort of body of four little stars that looks like the central star on a stone bridge, the central stone in a stone bridge, hence it's called a keystone. So the telescope is slewing. It's taking a picture and trying to center the object. So these objects, the globular star clusters, there's about 200 or 300 of them. They're very old structures, probably as old as our Milky Way, if not predating it, so it's found it. So what we will do, we'll put it in live stat mode. We will get the guide scope going. So it's guiding on several stars. And we will probably get by with 30-second exposures here. It's quite a bright object. And press the start button. So what you're looking at here is collection. Globular star clusters aren't as large as galaxies. They're not as large as the Milky Way, whereas our Milky Way contains about 200,000 million stars. Globular star clusters in the region of about 500,000 stars. Guiding doesn't look, it might be settling down now, but it looked like it went off a bit. We'll see what happens.
There's a great bank of cloud coming your way, David. So
Right, okay.
I've got total cloud cover at the moment.
Taking time to download the image. So that little green circle thing is trying to, whoops. Here we are. So our guiding hasn't, you can see when the guiding hasn't been successful. So what we will do, we'll stop that. And well, the guiding is like to settle down a bit now. So I'm going to restart. Sometimes if a cloud goes over and upsets the guiding, the telescope tries to slew to find the guide star, but it's behind the cloud. So it moves, but it can't find it, so it gets lost. So there we go, it's a bit sharper now. The stars are nice and round. So this the great globular in Hercules is one of the brightest of all the globulars. There's quite a few in this area. There's another one called M92. And there's an interesting feature here. Can you see the propeller? The 3 dark lanes. That actually is a genuine, it's always seen on this structure when it's photographed. It's called the propeller, but basically it's just the arrangement of the stars, I think, in the cluster. How it's actually formed, I don't know, but it's quite an endearing feature of this globular. Now, the other thing you'll begin to see as we build up the images is you'll notice a lot of the stars in the central part of the cluster are yellowy white. These are very old stars, but there's a lot of blue ones, blue stragglers. And these stars are actually pulsating variable stars. And over the course of the night, you can actually see these little blue stars winking on and off if you take a whole series of pictures of this object.
I'd like to add these. This is quite a nice object to look for a pair of binoculars as well.
Yes, through some of the large telescopes here, this actually takes on a three-dimensional look.
Yeah.
It looks like you're looking at a snowball. You're aware of its sort of almost three-dimensional appearance in the eyepiece. I'm just going to have a look and see if we've got any planets up there.
What's interesting here is that 10 years ago, we would be struggling to get pictures like this because all of the
Somebody called Peter's
we had
messages.
to
Thank you.
set our equipment up and essentially hope that our tracking is going well by itself. No guide scopes as such. So this has made life easy for the imagers to if you want to get about doing it, you can just buy the kit now and press the button.
Yeah,
So-
this is it. And the attraction is you can sit indoors in the warm,
Yes.
but you don't do what David did. David went to bed, and when he woke up in the morning, it was covered in snow, wasn't it, David?
Well, no, it wasn't that. What I did, I set the telescope going, and I went to make a cup of coffee. When I came back,
Oh, okay.
it was covered in snow.
Oh, don't. AI has already started to impact on the world of astronomy, hasn't it, David?
Sorry.
AI, artificial
Oh,
intelligence.
right, yes.
There's
Yeah.
a number of devices out there now which will clean up your images for you. But yeah, so it's coming.
Right, when this is finished, we'll stop, we'll save this image, and then we'll go and have a look at Saturn next. So Saturn is quite low down at the moment. Might have to move the scope then.
Okay. I want it.
Is there, do you have like a favourite time of year for this?
Yes, you do. Obviously, the planets drift around the sky in orbit around the sun. So up until Christmas, Saturn and Jupiter will be best placed in the southern sky. As we go through into winter, of course, we get Orion rising up, so we get the Great Orion Nebula. And then the spring skies, the Milky Way is lying over to the western sky, so allow you to look further out in deep space, so you can image all the galaxy groups in Virgo and Leo. So you can look in deep space in the spring. In the summer, you can see the wonderful nebulous objects in the Milky Way, like the famous Eagle Nebula, star-forming regions like that. So yeah, astronomy does have its seasons when the objects are at their best. We'll have a look and see if we've got it. Oh, no, never mind. We can ask it to plate solve. Let's do a longer exposure. So it's worked out where that star field was, and it was now going to slew, hopefully, to Saturn.
You mean if I've got to go back and check?
No, it should be all right. It shouldn't be too far off. Let's do a short exposure, 10 seconds. There we go. So what we need to do now is we image before those fainter objects, we were taking long exposures, 20 to 30 seconds. For the planets, they're a lot brighter. So you can do what's lucky imaging. You can take video frames and you can stack them together. But what I want to do, first of all, is just let's do, I want to get it right in the center, which would do 3-second shots. So these buttons, we can control the telescope in small steps. So the little dots around it are actually Saturn's moons. Brightest one is probably Titan. We've landed spacecraft on there. And the other is Tethys, Rhea, and Dione. It doesn't seem to be moving, doesn't it? Okay, well, I think that should be more or less near enough. So what we'll do now, we'll go into video mode. Increase the region of interest. So it's just down here. Let's hide the histogram. Zoom up. Wrong way. And we need to increase the exposure. Oops, what's happening? And we can increase the gain. Zoom in a bit. So probably looks like it could be a little tweak of focusing, but you can actually see the rings here and the globe, little moon down here. Let me go tweak the focusing a bit. We haven't got remote focusing here, so I'm going to go.
So what you're seeing is the effect of the atmosphere, the wobbling. It was amazing during lockdown when all the planes weren't flying, the atmosphere was so unbelievably steady. Yeah, it really was.
So how far away is that?
So what's Saturn?
Yeah.
About 90 million miles, is it? Well, no, I think it's about 145 million miles away. It's interesting, Jupiter rotates at 9 hours 55 minutes. Saturn takes 10 hours 55 minutes. The interesting thing is, in the winter, with these really long nights, it is possible to see in one night the entire rotation of Jupiter.
Is there something that you really want to see?
At home. Yeah, actually there is, but it's all in the southern hemisphere.
Okay.
Yeah. So if you go to Tenerife, there is an observatory up there on top of Mount Tidy, which is well worth a visit. And they show you through their solar scope. But the important thing there was the fact that you're looking that little bit further below the horizon to the southern hemisphere. One thing I would like to see is the great, there is a globular cluster south of the hemisphere that is absolutely superb. It can be seen with the naked eye, but even through binoculars, apparently you can make out individual stars. I did go to Chile once, but I was there for 2 weeks walking and it was cloudy everywhere.
Oh,
Now David's starting to focus that you
Yeah.
can start to see a band, a
Yeah.
belt. Well, that would be the ring. That would be the ring. The top bit. There. So, but there looks like there's something down here as well. So that would be one of the total belts. The belts on Jupiter stand out more than on a Saturn. Saturn tends to be a little bit more bland. It really, you're looking at the rings.
That make a difference?
Yeah, it did, David, yeah.
So, of course, Saturn's sort of a bit low in the sky, so hence all the shimmering you get, that's the atmospheric effects. But on a really clear night, you'll see a little gap in the rings here. So you might know, called the Cassini division. You can also see here a little gap in the ring. This is the shadow of the globe on the rings behind. The other thing you notice is it's got a red fringe at the top and a blue fringe at the bottom. That is our atmosphere acting like a giant prism, so it's splitting the light. So a red fringe here and a blue here. You can correct that with a called atmospheric dispersion corrector. Little prism you can alter in between the camera and the telescope itself. Good. That's as big as we can magnify it. You can use things like Barlow lenses and telenegative lenses that will increase the magnification, but it's a limit. The more you magnify an object, the bigger you'll get, but you'll probably lose detail. So what we can do, we can take a little video recording. So we do probably a 20-second shot.
Can you see the shadow of the planet on the rings at the back on that?
Just in here.
Yeah.
That's
And-
the shadow of the planet.
And once we've got a recording, we can then go into planetary stacking, press planet button here. This is a little video we recorded. Press stack. So what's that's taking all those little images, it was stacking what, 30, 40 frames a second. So it's aligning each little frame up, top the other one. Edit it. So what we can do here, we can sharpen the image and you can now begin to see the little Cassini division, this little black line appearing here. You can adjust the brightness. That's too bright. And you can adjust the contrast. So you can see you can just with a few clicks of the mouse, you get quite a good picture of Saturn.
You can see the bands of the atmosphere.
Yeah, this is
And that shadow now is quite sharp.
right.
Jupiter next.
Sorry.
Jupiter next.
Yeah, we'll stop that. What I will do, I will sync the mount on Saturn. That will probably help us find Jupiter. We might need you to go and move the dome, Dave.
I need the exercise.
Definitely.
Jupiter's still pretty low down, so it won't be a brilliant view. But we'll have a go.
While you're doing that, David, Dave was talking about the double cluster earlier on.
Oh, right, yeah.
I've taken a long exposure through the clouds and I've actually got something, which if you'd like to have a look.
Okay, I'm just going to press go to Jupiter. Going to stop sharing and then you share your screen.
Okay. I'm afraid it's not very good. As I say, I've got complete cloud cover here, but it did manage to pick something up. My guiding is very intermittent at the moment. So, are you okay?
Yeah.
Right.
Yeah, we can see that.
You see that? Yeah, this is the double cluster. Because I've got a wider angle telescope than the one in the dome, you can actually pick up both. But as I say, it's very, very fuzzy. I had to do a 2-minute shot through the clouds. I mean, normally I wouldn't use more than about 20 or 30 seconds for this, but at least you can begin to see what the sort of things that you can actually pick up with binoculars. So anyway, I'll put it back to you again.
Okay, thank you, Mike. See if it's found it. So Jupiter's in the east at the moment. It's quite low down. It stopped tracking for some reason. Not a good sign. It's not picking up many stars. So I'm going to lengthen the exposure time. I think it will be hard to plate solve that. It's only found a few stars. Never mind, what I can do, I can cheat, I can go out there and line it up with a little finder telescope. So bear with me 2 more minutes.
So just to explain, one of the other big innovations is place solving it like. This is where the equipment now can take a picture of the night sky, and it's actually got its own internal star maps, and it uses to match where it is, and then eventually it will use it to line up the telescope on the object. Works very well on deep sky objects, but it can be problematic on planets because they're very bright. They tend to wash out a lot of stars around them, so it can't do the plate solving. So David's going to do it manually. And there is a lot of software out there that's free, by the way, as well, for stacking your images. I'm going to say, I showed you pictures of images that I've taken with the digital SLR camera. So there is lots of software. There's Auto Stacker, there's Sharpcat, there's all sorts. There's Bus Equator is another one. There's lots of really good, and it's all free software, and it's all, and it'll download and it will stack your images for you. And then there is lots of good free software as well for post-processing, such as sort of removing problems, frauds, that sort of thing in your final image. And again, all sort of free. So yeah, there's some good stuff out there. There's some good stuff. One of the things I would recommend, if you haven't got it, is Stellarium. If you've got young children, they're interested in astronomy, if you're interested in astronomy yourself, it's a virtual planetarium. It's free software, and it is really, really, really useful. Really useful. And you can you can add your binoculars or whatever you're using, telescope or whatever, onto the system. Then you've got a button you click, and it will show you the sort of view and the sort of field of view that you could expect when you're looking at the object you want to look at, a big galaxy, globular cluster. And just as a site, they have found exoplanets around stars in globular clusters. And also they have discovered a planetary nebula in M30. And if you're interested, if you're into science fiction, many years ago, science fiction writer Isaac Asimov wrote a short story on a wall for it about what it would be like to be on a planet orbiting a star in a globular cluster. Very dense, lots of stars, bright stars in small space. Yeah, Mike, you got anything, Mike?
Yeah, if you want to just stop the share, I can just show you. I managed to get a quick shot of Jupiter, and I've actually picked up the 4 moons.
Oh,
Unfortunately, it's through the tree, so it's
not the dreaded tree.
Yeah.
Okay. So where's stop share?
should be down the bottom of the.
Oh, yours.
All right.
Yep.
Okay. Right. Okay. Can you see that?
Yeah, I can, Mike. There's a blue haze. Is that cloud?
It's cloud and leaves. Unfortunately, it's through the tree.
Oh, okay.
But you can actually just make out Jupiter, and then you've got the 4 Galilean moons.
Yeah. Okay. You're
That's the best I can do from mine.
Okay. Right, okay, thanks, Mike.
Right, there you go.
Right. Or should I share screen now? Yeah, hang on, Dave. What am I doing? Am I sharing screen, do you reckon, Mike?
I don't think you are at the moment.
Okay, all right. All right, here we go. That's better. Right, okay, Mike.
There you are now. Yeah.
Okay. Right, 84 stars. So yes, so what we would normally do is we would normally plan a session. And then wrap it in all sorts of.
Yeah, can I just make a comment about planning sessions, Dave?
Yeah.
Once people actually get their own telescope and so on, whether they're going to use cameras or not, there's a very good site called Telescopius, and what you can do is put in all the parameters of your scope, your eyepieces, your cameras, and so on. And it will actually tell you how much you can actually will be able to see. So it's very useful if you want to decide whether to use a wide angle lens or a something much sharper. So, but it's called Telescopius, so it is free, and I find it's extremely good.
Yeah.
And if once you get expert at it, you can actually get it to create mosaics for you. So if you wanted to take something, like a 3x3 mosaic of a larger area using a much sharper focus, it will actually create it for you, create all the details, and you can load that directly into the ASI Air, and it'll do it all automatically for you.
Oh, okay.
I think I know what's happened. I speeded up to move the planet, So what I need to do is log on again here. Right, now should have the right speed on. We need to increase that a bit. Come on.
Going.
It's gone too far.
Come back.
Tracking needs to be on.
Still going. I like.
Come back. Right, let's hope it settles down now. So it's a bit overexposed. So what we're seeing here, Jupiter is of course another gas giant. No, try that one. And the dark bands are called belts and the light areas are called zones. And it's a massive planet, about 88,000 miles in diameter. Oh, come back.
We've just lost it. You sure you shouldn't be pushing the up arrow there?
Well, it went up when I was, it went the wrong way, didn't it? Here it comes, is it coming?
It's shy.
No, I should zoom right through the bottom. Oh. Oh dear.
Now you can see how difficult it is without
It's not as easy.
decent tracking.
Perhaps I need to be a bit more prudent when pressing the buttons rather than keeping it fully pressed. Just give it a nudge. That's enough. Can't win, can you?
No.
Now, back in the day, we used to use just an ordinary little webcam, cheap webcam, and stick that on the end of your telescope and hopefully take a video and then process it. Now, we're relying on everything in one bit of kit to do the work for us.
Okay, I think it's- no,
No, we're on. For those of you old enough to remember the golden shot, burning the bulb, please.
oh no, I've forgotten which was me up, which was the down now. Well, we had it. Let's see if I can.
Well, the only other thing is, David, is what about Neptune? Is that high enough?
Yeah, we can try for Neptune.
Because you know what, I want to try for Neptune. And hopefully we'll see the moon. That's quite
Yeah, Neptune's a bit higher.
Am I going to go and even move this down?
Yes, I think it might be further round to the east,
Right, let's go
west rather.
Walk in the dog.
Thank you so much.
Okay, you're welcome. Thanks for coming.
Thank you, so we're coming on Sunday, so
Right,
see you then.
bye.
Bye, thank you. Thank you very much.
So the thing you wanted to look at before you disappear out the door.
This one.
We're on the edge of the bank of cloud. Oh, there
I
it is.
think it might be there with this
Yeah,
little,
there it is, yeah.
little moon. We'll just plate solve in a sec. Yeah, I reckon that was it.
Excellent. So that's Triton.
I reckon so.
Yeah.
Quite big, isn't it?
Triton is what, the third largest moon after
Is it?
Titan?
Yeah.
So it's centered it now. So it was Neptune. Looks like a little satellite coming through here. There's a satellite trail.
Yeah.
They're getting a real problem now. We're just on the edge of a bank of cloud, David.
Yeah, it looks, there's guide telescopes not picking up any stars. So we'll go into live stack mode. We'll do, yeah, keep it 30 seconds.
Can't say.
I think we're losing
Mm.
losing stars now.
Yeah. You're still all right to the north east. Cassiopeia is still clear. Perseus.
Oh, right, okay.
Yeah, let's go and check.
Thank you very much.
Okay, thanks for coming.
Very interesting.
Yeah.
actually. Thank you.
Oh. Yeah, so
Okay, folks on Zoom, we will call it a day there. We're going to lose the stars now. And it's probably time for us to say good night. Anyway, thanks for joining us. And we'll see you all tomorrow night if it's clear.
I hope it's clearer than it was tonight.
Yeah. Okay, many thanks, Mike, for your help as well. Bye.
Okay, good night.